Okay, integration by parts. So I'm going to go through this because I know Ryan was away. So hopefully you'll be able to watch this and get some of the questions done. So integration by parts. First of all, we're going to start with y equals uv. Now if I differentiate that, y dash equals the first times the derivative of the second plus the second times the derivative of the first. Now, that's okay, we know that. What I'm going to do is I'm going to take this over the other side. And I'm going to get y dash minus v u dash equals u v dash. I'm just going to rewrite this. So u v dash equals y dash minus v u dash. Okay, well that's good, but I want to be able to integrate. So I can integrate. Now, as long as I integrate both sides, and it's okay. So now if I integrate that, and I go with respect to x, by the way, with respect to x, I'm going to have the integral of u v dash dx equals, well, the integral of y dash is just going to be what it was originally. And here it is here. So I'm just going to get uv, because I differentiate with respect to x, now when I integrate, minus the integral of v u dash dx. And that is our rule. And it's going to help us integrate by parts. So let's take an example. If we want to integrate, so that's example 1, x e to the x dx. Now the hard part is choosing what you want to eliminate. Now in most cases, you want to get rid of this bit here. And when I say get rid of it, when you differentiate it, you watch what happens. So I'm going to let that be my u. Let u equal x. Therefore, u dash equals 1. Now, here's the other thing. That has to equal v dash. So dv dx equals e to the x. So therefore, v equals the integral of that, which also happens to be e to the x. Now I write it, and I write my rule every time. u v minus the integral of v u dash dx. So now my u is x, no worries. My v is e to the x, no worries. And in here, I'll get an integral that I can do. My v is e to the x, and my u dash is 1. See how we eliminated it? We eliminated the x, and now all I have to do is integrate this. And I've integrated it by parts. X e to the x minus, well, the integral of e to the x is e to the x, and there will be some constant. And that's it. That's integration by parts. So how does it get hard? Well, let's do another example. Let's do example number 2. The integral of x cos x dx. All right. Again, I think I want to get rid of that x, so I'm going to let u equal x, u dash equals 1, dv dx equals cos x. Now over here to my left, I go sine, cos, sine, cos, sine, cos, negative, negative, because it helps me integrate. So the integral of cos, which is going from here to here, is sine. So v is the integral of that, is sine x. And I write my rule. U, and what was it again? uv minus the integral of vu dash dx. Well, what's my u? X. What's my v? Sine x minus the integral of cos x times 1. That's just cos x. So this is easy. X sine x, and the integral of cos x, well, we just did that, minus sine x plus some constant. Except I messed up. Ridiculous. I wanted v, and v is sine x. And the integral of sine x is negative cos x. Silly, silly, silly. So x sine x plus cos x plus my constant c. Righto, let's do another example. Number 3. The integral of ln x dx. Well, there's no two functions in there, but I'm going to put one in. I'm going to say times 1. Put my dx in. So what will I do? Well, I'll let u equal ln x, and therefore u dash equals 1 on x, and dv dx equals 1, or v dash if that's how you like it, and therefore v equals the integral of that, which is x. So here, v minus the integral of v u dash dx. My u is ln x, my v is x, and I've got x and times 1 on x dx. So here I'll put the x in front, x ln x, minus the integral. Those x's will cancel, so I've just got 1 dx, which gives me x ln x minus x plus c. All right, 4. Here we go. The integral of e to the x cos x dx. Righto, this is going to be a bit harder. So I'm going to let u equal e to the x. And all right, I hear you crying out, oh, but that won't go, because when I differentiate e to the x, I get e to the x. It'll be all right, trust me. Now, dv dx equals cos x. I write my sine, cos, sine, cos, sine, cos. And integrate cos, v equals sine x. I write my rule, and I get uv minus, they look the same, uv minus the integral of v u dash dx My u is e to the x. My v is sine x minus the integral of sine x e to the x dx. Yeah, that's hopeless, Mr. Tonkin. We're sort of back to stage one, sort of. Well, over here, I'll do another integration by parts, and I'm going to let u equal e to the x, u dash equals e to the x, dv dx equals sine x. Back here, the integral of sine x is negative cos x. Okay, back to here. Don't touch this part in front, that's staying there, that's integrated. That part, by parts, has been integrated. I'm just going to integrate this part. And I'm going to integrate this using all this stuff I did over here. So again, I need a uv minus, and I'm going to put this in brackets, the integral of vu dash dx. So what do I get? I get e to the x sine x minus, well, what's my u? I'm going to keep it in brackets. My u is e to the x. My v is minus cos x minus the integral of vu minus cos x. I'm not liking all the meters here. My u dash is e to the x dx. Let's tidy this up. E to the x sine x minus e to the x cos x. I'm going to pull the negative out of here, which I can do, and put it out the front. You get a negative negative, so I'm going to get plus the integral of e to the x cos x dx. So now when I tidy that up, I've got e to the x sine x plus e to the x cos x minus the integral of e to the x cos x dx. And that is where we first started. So we're right back at the beginning. So here we're going to make a little substitution. We're going to say, let I equal the integral of e to the x cos x. You don't have to do this. So that's where we started. So these all become i's. This is I equals e to the x sine x plus e to the x cos x minus I. So over here I get two i's equals e to the x sine x plus e to the x cos x. I divide by 2, so I equals a half. I factorise out the e to the x, and I get sine x plus cos x, and there's always some constant. Sweet. Okay, let's do another one. What are we up to? That's 4. So let's do number 5. X squared cos x dx. All right, so let u equal x squared. Therefore, du u dash equals 2x. V, the v dx equals cos x. Therefore, v equals the integral, and again, this is so helpful, sine, cos, sine, cos, sine, cos. The integral of cos is sine. So, write it, uv minus the integral of v u dash dx, which equals, well, u is x squared, so x squared sine x minus v sine x times u dash 2x dx. Oh no, I'm going to have to do this part again. I've already done the front part, integration by parts. So I got this, that's good, I'm on my way. But over here, I'm going to do it again. So I'm going to get u equal 2x, u dash equals 2, dv dx equals sine x. Over here I've got my sine, cos, and the integral of sine is negative cos, so v equals negative cos x, and I do this bit now, so uv, and I put it all in brackets, uv, so 2x, what's v? Negative cos x minus the integral of vu dash negative cos x, and u dash is 2 dx. Keep it all in parentheses. So what do we get? X squared sine x. Let's take this part out. I'm going to get minus minus. I'm going to get plus 2x cos x. I'm going to get minus. I'm going to pull a minus out of here. Look at this. I've got a triple negative. Look at this. Negative there, negative there, negative there. So I am going to get another negative, negative the integral of 2 cos x dx. Man, I don't like that 2 there. I can pull it out the front as well. You can pull a constant out. Sweet. So the first part. The second part, and because we've whittled away here, the third part, the integral, didn't even put my s in for cos. The integral of cos is sine, so minus 2 sine x plus some constant. So after you get used to these, they're not that hard. 2 more. I'm going to do 2 more examples, then you need to get going. So number 6. Number 6 is going to be a triple. So I've got the integral of x cubed e to the x. Now, that integral of e to the x is never going to work its way down. But if I differentiate that, the derivative, if I differentiate that x cubed, I'll get an x squared the first time, and I'll get an x the next time, then I'll get another one. So this will take 3 parts. This one only took 2 parts. Yeah? This next one will take 3 parts. So stick with me. Let u equal x cubed. Therefore, u dash equals 3x squared. As you can see, we've whittled that down. dv dx equals e to the x. Therefore, v equals e to the x equals uv minus the integral of vu dash dx, which equals x cubed e to the x minus the integral of e to the x 3x squared dx. I'm going to do that again. I'm going to take that 3 out. Put it out the front. Okay? Just makes it easier. Get the constants out of there. U equals x squared. So u dash equals 2x, and v, the v dx equals e to the x, which equals v equals e to the x. So again, I do it. So I go here, x cubed e to the x minus 3, and what have I got here? I've got uv minus the integral of v u dash dx. So what is that? This part's done, x cubed e to the x minus 3 uv, x squared e to the x, minus in here, I get 2 e to the x times 2x dx. Tidy that up, x cubed e to the x minus 3x squared e to the x plus 3 the integral of, and I'll pull that 2 out from, 2x e to the x dx. And again, I will pull this 2 out the front. And 3 times 2 will give me 6. Sweet. So this integration is done. X cubed e to the x minus 3x squared e to the x plus 6. All right, so what's my u? My u equals x, u dash equals 1. My v dx equals e to the x. My v equals e to the x. I'm not going to write the rule this time. You should be trying to write it as often as you can, but I am putting in parentheses. So uv, so x times e to the x minus the integral of vu dash e to the x dx. All right, so we've got it down now. So what have we got? X cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 integral of e to the x dx. Oh yeah, we're almost there. X cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus some constant. Now you can factorise that e to the x out and you'll get e to the x cubed minus 3x squared plus 6x minus 6 plus some constant. Whoa! Okay. The next one, number 7, and the last one. Let's integrate giving away my secret there. Let's integrate inverse sine of x. Well, we're going to pretend there's a 1 in there. So, u equals inverse sine of x. Now, on your reference sheet, you get the derivative. And it's 1 on the square root of 1 minus x squared. Now, dv dx equals 1. You put that in there, so v equals x. Okay. Write your formula. uv minus the integral of vu dash dx. Okay. U inverse sine x. V x integral v x times 1 on the square root of 1 minus x squared dx. So you get x inverse sine x. Let's have a look over here. What am I going to get? I get x on 1 minus x squared. And you think to yourself, oh, this is cool. Let u equal 1 minus x squared. Therefore, du dx equals minus 2x. Therefore, du equals minus 2x dx. And I've almost got that over here. I've almost got that. I've got x dx. I need a minus 2. Well, we can do the hokey pokey. If we put a minus 2 in there and we put a minus 2 half out there, that's cool. So now my integration goes. My first part's done. I get plus a half. Now I'm going to get 1 on top, du, and I get u root u. I think to myself, this is looking really good now. X sine to the minus 1x plus a half, the integral of u to the negative a half du, which is equal to x sine minus 1x plus a half. Add 1 to the power of half, divide by that. Well, it's multiplying by 2. So 2u to the half plus some constant x sine of minus 1x. The half and the 2 will cancel. So I've just got u to the half plus c. But what was u? U was 1 plus x squared, or 1 minus x squared. Plus some constant. And it's integrated. So now we're doing exercise 2b, all questions. A lot of work there, a lot of work. Good luck.